UNC Energy Services is responsible for multiple services that power learning here at Carolina. Without their services, our campus buildings responsible for various purposes such as holding classes and housing students would have no electricity, cooling, or access to water, which would be pretty miserable. The division of UNC Energy Services this video will be focusing on is the chilled water system, which is responsible for the cooling of approximately 155 buildings across campus. The goals of the chilled water system are to produce enough chilled water to meet the campus cooling needs with 100% uptime, produce chilled water efficiently in order to minimize electricity and water usage, and plan and prepare for future campus cooling needs. The chilled water system is composed of 4 interconnected chilled water plants spread out around campus. The plants are connected via 27.5 miles of underground piping, and green and red caps can be easily spotted throughout campus that indicate where the piping resides. The system has approximately 44,000 tons of installed capacity, a 5 million gallon thermal energy storage tank, and 9.4 million gallons of total system volume. Inside the chiller plants, there is large color-coded piping running throughout the building. Each color serves a purpose. For example, purple is reclaimed water, red is steam, green runs between the chillers and the cooling towers, and the blue piping contains the chilled water. The darker the shade of blue, the colder the water is. The employees of the chiller plants are able to monitor and manage the plants via a computer program called SCADA, which stands for Supervisory Control and Data Acquisition. Other examples of equipment used in the water chilling process are variable frequency drives, heat exchangers, sand filters, RTVs, and electric panels that are handcrafted by the employees at the plants. So what is chilled water? Chilled water is water that has been deliberately made cooler by means of a refrigeration cycle. The refrigeration cycle takes low-pressure vapor and sends it through a compressor where it comes out high in pressure. From here, it's pushed through a condenser, which turns the vapor into a high-pressure liquid. Then, it travels through the expansion valve, which returns the liquid to low pressure, and the cycle loops from here. The cycle works in tandem with the chilled water and condenser water cycle to cool the buildings and equipment on campus. The chilled water loop takes the low-pressure liquid from the evaporator and transports it via underground piping to buildings on campus. As the chilled water runs through the campus buildings, it absorbs heat, thus cooling the buildings, and the heat-absorbed water is returned to the chiller plants to cycle back through. The exit temperature for chilled water is typically 42 degrees Fahrenheit, and the water is usually returned at 55 degrees. The chilled water loop is a closed loop, meaning the heat transfer cycle is not open to the atmosphere and there is a low makeup water rate. The condenser water cycle differs in that it is an open loop system, meaning the heat transfer is open to the atmosphere and therefore the evaporation and makeup water rates are high. In the condenser water cycle, the hot vapor is extracted from the condenser and is cooled via the cooling tower, which works by bringing the vapor and water into contact with each other, thus causing the water to be evaporated, which reduces the temperature of the water in the tower. On top of the tower, there is a fan that is 20 feet in diameter, and this helps aid the process. The evaporation that occurs causes water to be lost in the process, and this cycle uses approximately 200 million gallons of water a year. Because of the high water usage, the plants have begun to use reclaimed water to refill. In order to maximize the life expectancy of equipment, keep power consumption low, and prevent downtime for cleaning, water treatment is required and necessary. More specifically, water treatment is needed to prevent issues such as fouling, scaling, microbiological growth, and corrosion. These issues can lead to reduced productivity, increased repair costs, a delayed production schedule, and decreased plant efficiency. Nalco is the contractor hired by UNC to supply chemicals and create a water treatment program to fit the needs of chilled water. They monitor the system continuously with the use of 3D TRASAR units. The system sends alarms, notifications, and manages inventory. Without Nalco, the chilled water plants would likely have an extremely difficult time supplying the campus needs with chilled water. UNC is committed to net zero water, zero waste to landfills, and net zero greenhouse gases. The chilled water system is responsible for Carolina's commitment to net zero water, and as previously mentioned, the plants have begun to use reclaimed water in an attempt to conserve potable water. They made this change following the record drought in the early 2000s when the university partnered with OWASA, which provides reclaimed water services. In 2019, the university had reduced its potable water consumption by 43% since 2007. Overall, UNC Energy Services is a crucial resource for the success of the university, and the university would not be able to run properly without their hard work. Anyone who has experienced the sultry summer months in Chapel Hill can understand how important the chilled water division of energy services is.